a look at this spring example. So it says an unstretched spring has a force constant of 1200 newtons per meter. How large a force and how much work are required to stretch the spring by 1 meter from its unstretched length and then 2 meters? So kind of the idea here is we're looking and seeing what happens when we double the amount of stretch. What happens to the force and what happens to that potential energy. So if I do stretch it 1 meter, okay, so let's do a 1 meter calculation. So in this case, the force is going to be my 1200 times my 1, so it's going to require 1200 newtons per meter. So the spring constant was 1200 newtons. Oops, let's change that around. Newtons. So my spring constant was 1200 newtons per meter times my displacement, which was 1 meter. It took 1200 newtons. Now for the potential energy, it's going to be 1/2 times 1200 times how far we stretched it squared. Okay, so I do 1/2 of 1200 times 1 squared. It's 600 joules. All right, so it takes 600 joules to stretch it that far. I do have to be kind of careful when we do potential energy because this force is changing with distance. I can't just do what's this force, 1200 times how far did it stretch, 1 meter, because 1200 times 1 is not 600. You do have to use that potential energy function, or if you're trying to find more of the work, you're going to have to find the area under the force versus position graph. If we're in the scenario of 2 meters, what happens then? Okay, so now my force is equal to 1200 times 2 meters, so it's going to require 2400 newtons. So if we double the displacement, it's going to require double the force. Now when I get down to the energy or the work required, because I'm going to have to store that energy, it's going to be 1/2 times 1200 times 2 squared. And so this is going to come out to 2400 joules. So to stretch it twice as far, it's going to require 4 times as much work because I need to store 4 times as much energy in that spring. So getting at that idea that work is a transfer of energy in and out of kinetic energy. So when we do work to stretch a spring, we are applying a force over a displacement, but we're trying to give it kinetic energy, but it's just storing it as potential. We're adding kinetic energy, and then that kinetic energy is being removed by the spring and stored as potential energy. There you go.